I'm honored to be here to receive the Alumni Merit Award, and I'm very humbled by that honor, and I thank you very, very much. You know, coming back to Ann Arbor, though, this time of year is really fun. You see all the leaves, the colors changing. I'm from Northern California. We have basically wet and dry season. So although you might complain about winter, we don't really get the 4 seasons. And it's just fabulous to have that feeling in the air. I mean, the air just feels different. And walking around and having that spirit and the freshness of the fall season and the energy in the students, it's wonderful. And it's a little different in that I had gone to school here at East Engineering, where all my classes, and all the labs were in the basement, so we didn't get as much sunlight as you do here. One of the things that was, very special for me in the fall was football. I loved it. I wanted to continue to play football from high school, but quite bluntly, I just wasn't talented enough. But I really enjoyed Michigan football, and I just thought I'd get a show of hands. Who here enjoys Michigan football? Can you raise your hand? Okay. Of those people here, who here loves Michigan football? Okay. Well, then you'll enjoy, those who especially love it, I think will enjoy parts of this presentation. Going to my first Michigan football game and singing the victors, and this whole thing about leaders and best. And, when at the time, Bo Schembechler was coaching, and with all the Big Ten championships he had, leaders and best just rang very true. And there was something about that created all that energy and passion and allegiance. And when I came to East Engineering, I didn't have that same feeling, to be honest with you, connecting leaders and best in engineering school. And it wasn't that I didn't like it. I loved it. I loved solving problems. I loved designing computers. But there was some gap between inventing stuff and this notion about leaders and best and creating a difference. And so I want to take the opportunity today to share from my experiences where you might cross that chasm between invention and creating some real value and being leaders at best. The 4 or 5 years ago, I don't know exactly when it was, we had this West track where we brought engineering students, and it was Thomas Zerbuchen and Dean Munson that helped bring this idea into fruition, and trying to transplant ideas and collaborate with what's going on in Silicon Valley and share how value was created there and how innovation occurred with what was going on here at the University of Michigan. And that was great. Was it 5 years ago, 4 years ago?
One or the other.
Yeah. Time has flown. I mean, for me, it's flown. And I'm here today to say basically the competence and the critical matter of innovation exists here. It exists in this department of EECS. And the question is, how do you take that innovation and transform it and put it into action to create something that's very meaningful and that has value to you? And that's what I'm going to be talking about today. So first of all, I'm going to talk about taking great ideas and putting them into action and sharing a framework on how to do that. Next, I'm going to create an application of that framework so you can actually see how the framework can be put to use. And lastly, I'm going to talk about opportunities for EECS, where you can go with this. What is value creation? I think you first have to define success for you. Success might be being the first one in your family to get a college degree. Success might be for you filing your first patent. Success might be for you reading The Little Engine That Could to your grandchild. It could mean different things. And success is very personalized based on what's important to you. And when we talk about value creation in this discussion, in this context, I'm using it to mean an impact on others. The ability to change someone else's behavior and their life so that they have incremental benefit that's sustainable benefit without very much effort at all. And of course, being an engineer, I had to use a formula. And I think that the formula that I like to introduce to you today, and I'll define each one of these terms in this framework, is disruptive innovation added to or combined with creative destruction equals value creation, okay? Now, creative destruction is a term that's been used for a couple hundred years. Sociologists from Germany, it was followed up by an economist in Austria, and then you find it in business schools and a lot of rhetoric, but it was really started back thousands and thousands of years ago in the Hindu belief of Shiva. If you know of anything with the god of Shiva, represents the duality of both destroying and creating. And there's this cycle, the notion of a cycle of destruction leads to creation. And these cycles are an essential to have growth. And we're going to talk about how do you formulate that creative destruction and apply your disruptive innovation to it to get the value creation. And there's basically 3 different concepts that I would suggest are required in order to come up with creative destruction. First, culture. Second, passion. And the third, expertise. And it's not 1 or 2, but all 3 of these combined and how they overlap. And when they overlap, combine with disruptive innovation, that you get true value creation. And when you do that, you get leaders and best. Okay? What's expertise? I would argue that expertise is a lot more than skill. Denard Robinson is on the cover of magazines, is talked about in the news, the sportscaster being a Heisman Trophy candidate. He didn't even start last year as quarterback. Is he running faster than last year? Is he taller than last year? What's changed? I think what's changed is he has a lot of experience. He takes the skill and with a lot of reps, doing something very, very well, has perfected it with experience that then becomes intuition. And that leads to expertise. So I define expertise to be something very, very different than that of just plain skills and experience. Before I leave that, I wanted to share something about expertise personally. And when I work through this, I'm going to give examples of Michigan football and then personal examples of myself on how the model works. When I was working on my graduate degree, John Hayes sponsored Larry Riggi and I, who were students together, on fault-tolerant computing. And basically, we came up with an algorithm and a thesis on how to prevent a system failure from any single point of failure. And we enjoyed working on that project together. We actually worked really, really hard on that project because it was more of a pride thing than anything else than a grade. But then when I left the University of Michigan, I actually did not become a computer designer, believe it or not. And I went into management, and I went to a management development program. I'll talk more about that in a little bit. But you figure, how could you ever use this? And not only did I go into this management development program at AT&T, which rotated you through different assignments, different functions of the business to gain experience, and they typically put you into real trouble hot spots to fix and then go on to the next spot. And that alone kind of created some distance with me and some of my professors here, because it was like, we trained you to be this great computer architect and now you're wasting all that skill. And that was the feeling probably I had more than they had, but I felt a little distant. And then one of the rotations I went into was in sales. And then when I went into sales, I have to say I felt like I was banished for a while. Now, George Haddad accepted me back into the wings here, which I'm very happy about, and hence I'm here today. But when I went into sales, like, how possibly could you ever use anything you learned designing computers in sales? Well, I actually did. That work I had done on fault-tolerant computers, it came to an opportunity with one of my accounts, First National Bank, First Chicago. And they basically had one of the biggest campus communication systems in the United States in downtown Chicago and the suburban area. I had a quota that I had to work with all my accounts, including them, and they had all the best and the brightest, so I couldn't think for the world of me how I was ever going to increase sales for these people. I was concerned about not losing revenue. So it dawned on me one day when the guys on the data side, IBM and all the Burroughs and when there was a Burroughs and all those players were in there, and they were feverishly working on something for a disaster recovery plan, because it turns out that the Office of the Comptroller of the Currency requires all financial institutions to have a disaster recovery plan. Well, I was scratching my head and said, well, you guys are all working on this data. What's their voice plan? So I went to the guy in charge of all voice. I said, what is your voice data recovery plan? He goes, what do you mean? And it dawned on me that, you know, the computer systems went down all the time. They actually had downtime plan outages. It was part of an operating behavior. We're planning downtime. You don't have to work for this hour. But if you ever picked up the phone and you didn't get dial tone, it'd be considered like there must be a war going on. You just always expected dial tone. It was very reliable. Well, so it was kind of a tough sell to say you need a disaster recovery plan for your phone system. But I did because I said there's this edict from the government. And since you had that, you have to comply. And it actually stuck. And so basically what I did is I took what their star configuration was with a campus where they had many single points of failure that would bring down the system, applied the techniques of fault-tolerant computing, put an overlapping ring campus topology in there for communication systems, and $5 million later they had a system that worked for disaster recovery in case there was ever a disaster. Now, just to prove I wasn't just a commissioned grubby sales guy, it was actually 2 years later that a contractor with a backhoe on the Lake Michigan ran into a pylon. And you might know that Chicago, like St. Louis, has a whole underground. And that flooded the entire underground in Chicago and knocked out businesses left and right. And many businesses never recovered. And some businesses moved out of downtown Chicago forever. But I'm happy to tell you that that communication systems, other than the one node that went down that got flooded, continue to work. So the moral of the story is that although I developed that expertise, that skill of fault-tolerant computing, until I had an environment or experience set that I could apply that to, it really wasn't an expertise. So it requires both. Okay, next is culture. I have a question. Well, first of all, I have to say, when I was in engineering school, I don't think culture was ever mentioned. I don't think the word ever came up. And I'm not saying that's what going, because I got that engineering brochure, and that was brilliant. I mean, the combining of the disciplines with the arts, and also I see there's real culture going on here and intermingling between the disciplines, which I think is great. But that wasn't the case in the basement of East Engineering. So, to me, there was, you know, the football team oozed and oozed of culture. And that really impacted me and had a great, lasting, formative experience on me because I see what culture can do. And I'm going to show you an example right here, but before I do, does anyone know here why this banner got put up?
I think in Schembechler's first year, so many of the players were quitting because it's so tough the camp and the training that you put that up to say, well, if you remain, you're going to be.
That's the right answer. There's a winner. That's right. That's great. A lot of people don't know that. They think it's a takeoff in Notre Dame, like play like champions today. It was because he was losing players. He couldn't keep the team together. And so he developed a speech that you might have heard of that I'm going to play for you right now, which was talking about not the individual, because he had a lot of great athletes, but they were going other places because they wanted to be greater, and they didn't feel great. And what he did is he wanted to create a culture is all about creating a common value system that everyone's aligned on. And that's not easy to do, especially when you have a lot of diversity and a lot of individual talent. And so he wanted to talk about how do we bring that all together. So I'm going to play this for you right here to give you a feeling, not just, you know, intellectually understand, but a feeling of what developing a culture is all about.
We want the Big Ten championship, and we're going to win it as a team. They can throw out all those great backs and great quarterbacks and great defensive players throughout the country and in this conference. But there's going to be one team that's going to play solely as a team. No man is more important than the team. No coach is more important than the team. The team, the team, the team. And if we think that way, all of us, everything that you do, you take into consideration what effect does it have on my team. Because you can go into professional football, you go anywhere you want to play after you leave here. You will never play for a team again. You'll play for a contract, you'll play for this, you'll play for that, you'll play for everything except the team. And think what a great thing it is to be a part of something that is the team. We're going to win it. We're going to win the championship again. because we're going to play as a team. Better than anybody else in this conference, we're going to play together as a team. We're going to believe in each other. We're not going to criticize each other. We're not going to talk about each other. We're going to encourage each other. And when we play as a team, when the old season is over, you and I know it's going to be Michigan again. Michigan.
Yeah, Bo Schembechler had a huge impact on me in my life. And, whenever I hear that, it chokes me up. It was like it was just yesterday. And, like a lot of other people, you loved Bo a lot more when you weren't, playing with him. He became a very good friend after I left school and all. And, the leadership values and the things that he did really impacted me. And so he had a really tough challenge because he challenged the status quo in a very, very big way. And it's tough to play football when you don't have any players on the team. So he had to do something about it. And he created this reward system about teamwork. And everyone believed in that reward system, and they aligned on that system. And so, it's not always the first person who invents something that becomes the winner. And I'm sure you've heard that many, many, many a times. But he who comes up with the first great idea or invention isn't the person who necessarily gets the most out of that innovation. And in fact, there will be defectors. So another personal example of mine is the first computer design course I had was on the Z80 in the basement of EECS Engineering, which was an 8-bit microprocessor. And then from there, we moved to 16-bit and then 32-bit on the Motorola 68000. And I actually became a TA in that lab. And as I was working there, it became very apparent to me that the students, I thought, were getting a lot more when we were teaching Z80 stuff, designing much more logic, much more computing power than on the 68000 when they were spending all their time just learning the instruction set. And it kind of dawned on me that also the principles of pipeline computing and parallel processing and all really weren't being exploited because everyone was depending on this big, huge, gigantic chip. So instead, why don't you have a smaller reduced instruction set computing technique rather than complex instruction? And I had done some research on it, and I knew there's some stuff going on at Berkeley. And I was asked at lunch before, when I was speaking to some professors before, who was my advisor on this? And actually, my advisor was kind of Norm Scott, only because I couldn't find anyone else who thought it was a good idea. And actually, they thought I was crazy, because all the research, all the backing, all the dollars, all the marketing was all around going complex instruction set computing. And so what did I have to do? I had to figure out a way to create alignment. And so, the one thing that's great about engineering is we always rely on data. So that became the common thread. So I worked up not only design, but worked up benchmark testing. It actually took me as much time to develop the simulation testing as it did the design itself. But the simulation ran across different functions, and then I basically went to specifically two professors who doubted my work and asked them to run their tests and their architecture versus what I had done on RISC. And not all the time, but the vast majority of the time, the RISC architecture proved to be a lot more, not only faster, but more productive. So that was a win for me. I really didn't make them happy. But that's all about the factors. But the notion is you go from there. You go from there by establishing a common ground on which you can get support. And that's very, very much important, I think, in any culture if you're looking to change the status quo. The other thing that's important, I believe, is passion. Now, passion, some people might think that, hey, my passion for football is absolutely ridiculous. It's over the top. Or that someone else's passion for, baseball is over the top. And the thing about passion is it's very individual. There's not a right or a wrong answer. It's what's in your heart. And it can be in your heart for a whole bunch of different reasons. But, engineers have hearts just like all the liberal arts students and all the business students. I'll take that back on the business school students. I really think that you got to trust your heart. In order to do that, you have to know what you love. And so I would spend time understanding what you love and what's most important from you. And you could say, well, what's so special? Oops, that's magical.
Yeah, passion.
Oops. So I'm gonna share something with you, and it may or may not evoke any kind of reaction of
For
passion.
nearly a century, these two fields have seen history made and legends born.
You don't even have to say Desmond Howard, you can just say Heisman Post.
For the Michigan Wolverines and the Ohio State Buckeyes, the greatest rivalry in college sports is about more than football.
This is a rivalry between two ways of life.
The one thing that he said that really stuck out with me, he said, this is more than a game. This is war.
Buddy Hayes is furious. You have to understand, football is a secular religion. You feel you are a part of something that stretches from before you existed and will be here long after you are gone.
Michigan versus Ohio State, the rivalry.
So you might say, this is kind of crazy. Get this excited about an annual football game? And I went to high school in Ohio. And it wasn't until I came to Michigan that I got it, all the passion, the history, because it wasn't just about a game. It was around a rivalry. And some of you may have that more with Michigan State because of the upbringing of families and the history behind it and the tradition behind it. But again, I think it becomes a very personal thing, and then certain things in life have a symbolism of what those passions are. And those are things that are very important to follow. And I think passion is really, really important because what it does is two things. It allows you to become maniacally focused around something that's very important, even when things get really bad. Because things get bad when you're trying to do something very different and change the culture, change the status quo. And unless you're willing to be fervent about your own passion and dedication to overcome failure, it won't go. You know, Thomas Edison, I think, said it best when he said, I didn't fail 1,000 times creating the light bulb. It just took 1,000 experiments before I finally got it right the first time. And that's passion. I list here things that I think are pretty obvious about being brave, not stupid. Do important work. You don't want it to be kind of a short-lived kind of passion. You want it to be something that is everlasting and something that you truly love. For me, I had a situation where I had to pay for my own school. So every spring break, I would be working. And I told you about this situation where I had done this risk architecture. Well, some of that work got out. And for my last spring break, Harris, Larry Riggi knows all about this, but Harris Computing invited me to go down to Melbourne to interview. And they put me up at this incredible hotel right off the beach and spent 2 days meeting with people, smart people, wining and dining me. I thought I was going into the NFL. It was unbelievable how they treated me. And they wanted me to be one of their 5 to 6 people on their project team that they were going to launch in San Diego. And it was very, very exciting. And they paid for my flight down, and they paid for my meals. They even paid for my gas and my rental car. I just said, this is great stuff. I know exactly what I'm going to do. We had a great time on spring break, which they essentially paid for, except for the beer. And I came back, and then one night, I got this knock on my apartment door, and it was a representative from Fairchild. And they were launching, or they wanted to design a new chip, and they wanted me to be part of that design team. And I was very humbled by this person flying all the way to California unannounced to come talk to me about their new computer chip. And he left, and I had this empty feeling, to be honest. And it kind of had started actually not because of some of the people that I met who were going to be on that design team for the new supercomputer for Harris, but what I thought my life was going to be like, working with that small 5 to 6 person team, 18 hours a day. And what I realized is that my passion around working with people and solving people problems as well as technology problems might be lost. And so I had to do something that at the time was very, very challenging for me. because the uncertainty about doing something else other than designing computers was a challenge. It was scary. And so I had an interview with Bell Labs, and it was already scheduled. I didn't want to cancel. And I went in, and they're talking, and halfway through the interview, said, I'm not sure I want to design chips anymore. And they looked at me and go, why? And I told them why. And they said, well, that's okay. We have AT&T, and they have this management development program. Why don't you interview with them? And that's what I ended up doing. But if I wasn't willing to be brave enough to share what my true passion was, I couldn't share it with anyone else, and no one else would be willing to help me. So I think that's a very important part of passion. It's not only to have it, but to share it. And there's nothing wrong about being a computer architect, design engineer. I think it's great stuff. It was just something that, for whatever reason, wasn't in my heart anymore. Maybe because I had done it too long. I don't know. So I think the tagline there is, you can't make decisions and at the same time leave your heart behind. Now, the framework that we've talked about so far for creating value has been mainly around this, this whole notion around creative destruction. And of course, there's the other piece that we need to include with that, which is close and near to dear to your hearts, which is disruptive innovation. You need both in order to be leaders at best. What is disruptive innovation? I'm going to create some very strict definitions on this because I think the definitions, the vocabulary is important, because the vocabulary is then what you use and how you think. So the definition I'm using for disruptive innovation, because other people use it in journals and other places I've learned when I was preparing for this talk. And in our firm, we use disruptive innovation. And so I'm going to refer to the terminology we use at our firm. Number one of three is you're obsoleting existing technologies. You're creating an order of magnitude improvement in productivity over a technology than what exists today. Two is you're shifting industry business models. So in other words, you're creating something a lot more accessible or at a much lower price. And the third is you're expanding a market with new applications. So the market does exist already, but because of the way you're approaching it, there's all types of new utility that's available. And the bottom line from the world I work in early stage venture capitals, disruptive startups have an inherent defense against competition because incumbents are unable to respond without unraveling the current business. Can someone else name for me a disruptive innovation by this term? Anyone? Anyone? And what's disruptive about it? Okay, I'm glad you said that. So this is very helpful. And in fact, I give you a book even though it wasn't the right answer. Disruptive innovation is something that has been adopted by a lot of people because it is disruptive. So if it's going to be, it's still not disruptive yet. Anyone else? For sure. I mean, look at all the international calling that takes place today that didn't take place before. Absolutely. That's a great answer. So I'm distinguishing disruptive innovation very much from invention. A simple example to me is this. Most people might say that actually the introduction of the automobile was disruptive. It's disruptive innovation. It wasn't. Most people kept riding horses because they couldn't afford that car. The disruptive innovation was the Model T, which became not only accessible because of price, but it was very durable and it didn't take a lot of maintenance. So that was the disruptive innovation by this definition. So, I'll give you examples here on business models. These over here on your left-hand side, these are typically distribution plays. In other words, because the distribution becomes so much easier and lower cost, it creates much more accessibility to the same product in a market that already existed. And on the right-hand side, you can see, and I'm sure you can guess what those are without me going into them.
So it's technology maturity. I mean, technology has to be mature enough that you can apply it.
See, I'll tell you this, from a customer or end user standpoint, they don't know what mature technology is. They know what easy technology is. They know what saving money is. They know what higher productivity is. So they don't look at technology from anything other than a productivity or a cost enhancer. So I think in terms of how we want to think about things relative to the model and framework I'm introducing, again, there are many different terms and ways of looking at this, but the way I'm defining it in this framework is that it's got to be embraced, absolutely. And it's not to discount the first automobile, but it really is to more emphasize that what it's all about is impacting other people's lives, okay?
Think of mobile broadband, is that disruptive or not?
You would have to name an application for me more than that, right?
Mobile broadband, you can carry your Wi-Fi any place you want.
Right, so I think what was, what I think was disruptive was at the point where the price of mobile broadband and the reliability of it was more ubiquitous.
Well, I took, for example, a mobile broadband, and I have a Vantage system in the house.
Yes,
And I converted actually the Wi-Fi to a LAN, and because I need to connect it to the Vantage system because you have to have a high-speed internet.
right,
And so that was disruptive because I canceled all my charter cable and I canceled my all my AT&T because these guys are pretty lousy in charging as much as they can. So
Right.
That's disruptive innovation.
so that's important. So the bundling of different services was very disruptive in pricing, absolutely. And that would be totally an innovation, disruptive innovation. So in other words, the difference, and this is what we're getting to, what's the difference between an invention and disruptive innovation? An invention is a new idea, new technology. Very important to do, but a precursor to disruptive innovation. And the formula that I introduced, the framework, it wasn't about invention plus creative destruction. It was about disruptive innovation. Okay? So I just want to kind of emphasize that. And just to play with this so we kind of sink in this concept. Because I think at times when I talk to very brilliant people, that they a lot of times will focus on their invention. And in my role as a venture capitalist, I actually can't do much with inventions. Because licensing technology is great, and Johns Hopkins has made it a business, and they're allowing other people in the world to make a difference. I think you guys at Michigan can make the difference. You don't have to wait for someone else to do it for you. What is this a picture of? Okay, that was right. I don't know who it was. Was it a jump ball, or
I knew how to jump.
was it two simultaneous? There he goes, pan back two. Okay, that is correct. Okay, we'll take it one step. And when was it invented? 1947, absolutely correct. Okay, 1947. Okay. And where was it invented? Oh, I don't have enough books. Okay, all those are right answers. Who's this fellow at the top of the page? Marita's son. There was a company precursor to Sony, and he ran Sony, right? So that's close enough. Oh, you got one. Okay.
He's a good student.
So, and how much did he pay to have a license to the transistor from Bell Labs? Okay, speak up. You got to be brave. What did I hear? What did I hear? So I heard someone say it. 50,000. It's debate. Most people say 25, but some people say 50. So 25 to 50,000 he paid for a license to the transistor. Okay? And with that, he created the transistor radio. The transistor radio, I would argue, was a disruptive innovation. The transistor was an invention. And with that, he created a whole company of products with transistors and improved upon this technology with all new technology, okay? And I think that is the continuous loop of disruptive innovation, because when he does that, what is he doing? He's destroying his base of technology, the transistor, with new technology. And that cycle of someone who's willing to create that destruction and creation, that's what's sustainable. And that's why typically big companies stall, because they no longer want to destroy what they created, because They're all too wealthy. And why would you want to change a good thing and cannibalize yourself? And that is what creates the opportunity for new attackers, for entrepreneurs, for people to come to the market, because the big guys don't want to make a change. So, in my world, success is defined by, of course, being an engineer, I got to use formulas. And as David Packard said, if it's not worth measuring, it's not worth doing. So, return on investment, it's the total returns of all the portfolios that are made, portfolio investments made from the fund over the fund size. So, and this is how we do it. This is basically our disruptive innovation approach that we use combined with something else that we call capital efficiency that I won't go into. Okay? Now, what is the success for EECS? I would suggest it's return on your time. And how do you define that return on your time? With disruptive innovation plus the culture, passion, and expertise that you apply together with the limited time you have. And the time is really important. And that requires focus. So you got to decide what you want to do, but more importantly, you have to decide what you don't want to do. And that might be to the chagrin of some of your professors or some other people, but I think that's very important to learn to focus. So focus your efforts to develop disruptive innovation and leverage expertise, culture, passion over time. So next I'm going to get into the application of this framework. I'm going to try to move through this a little bit more quickly. Here are portfolio companies that Gabriel Venture Partners has invested in. And I'm going to share each one of these have had a different characteristic under this disruptive innovation. Chegg is a disruptive business model. In essence, it took a market, college textbooks, and allowed students to pay 1/3 the price and for the exact same product. So that's disruptive because students ask, well, I can either go and buy the book or I can rent the book and I can have another $70 for beer. Okay, I got it. Aurora Biofuels. This is a company that basically takes algae and turns into biodiesel fuel, as well as into other products like omega-3, other food supplements. And this is very disruptive, not only because it's clean, because this whole clean tech thing is really, really big, but it's disruptive because it's price and cost competitive with processing crude oil. And that's why it's competitive. And I'm not going to knock anything with windmills or solar and all, but a lot of solutions that are alternative are dependent upon the price of oil being pretty high. And so this being competitive at I think it's a $40 a barrel, and I think it's much up from there right now, makes it very, very competitive. And so this is on a disruptive technology for us, how we define disruptive technology. The last one, NextG Networks, does both. It's actually a disruptive business model that's been enabled by a disruptive technology. This company had a technology called DAS, Distributed Antenna System Technology. It allowed you to, in essence, have a miniature antenna that allowed you to put it on a lamppost or side of a building, but in areas where the zoning was such, you couldn't put up a cell phone tower. So in places like Palo Alto, where it's a community where they don't want to have that eyesore, or municipalities where they can't just put up a tower, this was very attractive. And so what they did is they took this technology and they went to the major wireless carriers and said, listen, we'll take care of all that dirty work of getting the microwave signal in places that you can't even get to your central office. And we'll do it at half the price. And what they did is they bought up a lot of cheap spare capacity dark fiber, okay, to the central offices. They put up an antenna somewhere, they got clearance. They put one carrier on that system, and it basically paid for the whole project, so every other carrier that came on top of it, because they did this kind of basically shopping mall business model, where they aggregated it all onto the dark fiber, became very, very profitable. Of all these companies, these are all still companies that are standalone private companies today, but I'm hoping Chegg goes and gets publicly listed next year. And we're going to use Chegg, because it's, I thought, closer to home for you guys, as an example of applying the framework. So I think you get it. It's pretty simple. They basically find out what books you need, and you order it online, and they ship it to you. And when they ship the book to you, they also ship the return envelope. So all you got to do is remember where that is, and at the end of semester, return it. So the first part of the framework for creative destruction is passion. And all the people involved with starting the company, including me and helping them write the business plan, was highly, highly passionate about the cost of going to school. I thought like how much I had to work in a factory while I was going to school in order to pay for my books. And if I could have done a third of less of that and spent my money somewhere else, that would have been huge. So I was pretty passionate about that. And the founders of the company were pretty passionate about it too. And the students obviously are passionate about it. What's disruptive in terms of the innovation around this? Well, what's disruptive is you have this oligopoly, these three, in essence, publishers, one of them out of Ann Arbor, Follett's, who basically are running the roost, who are gouging students with high price of books, and then not only that, but creating multiple versions within insane short time periods. Like the information couldn't have changed because the three authors of that economics book have already died. But they kept turning new editions to create more profits. So create a ripe opportunity for someone to come in and price below them. This is not simple. And in fact, with most startups, this is the thing where people get blindsided, is the culture, the ecosystem. You do not stand alone. There are other people within the ecosystem which you operate within. And you got to be very cognizant of it. In college education, it's pretty complex. There's all these different players there. And if you say, well, I'm just going to be better than everyone else, and I'm going to do this on my own, you're not paying attention to the interdependencies that really exist within the market. And what will happen is they'll cut you off at the knees. And whether you can say that's illegal or whatever, it doesn't matter. It's what will happen. So in the case of Chegg, they created partnerships and going to some schools and actually have kiosks in the bookstores in which they rent books. They work very closely with the publishers and giving them kickbacks on the profits we make to make sure they're happy and they supply us books. We're working on the professors, but I was working with the the provost here, Terry, before she left, and I haven't really been successful kind of starting that back up, but we're working with professors to let them know this is a good thing for their students. The people who are kind of most upset, of course, distributors and wholesalers, but you can't make everyone happy, remember. You're not going to make everyone happy. What is the expertise in renting books? You probably say, well, anybody could do that. Well, you think of Amazon, right? Amazon takes product out of a warehouse and ship it one direction. Chegg has to not only ship it, but then bring it back and catalog it to go and send it out again. It's very complex, actually, the logistics around that. And we brought in the person who ran all logistics for the Army for Afghanistan to help run this for us, because it's very complex modeling. Additionally, data mining. If you go rent the wrong books, you're going to screw up your margins. Like you can't go rent the classical novel in paperback. I mean, you're never going to make a buck. It's much cheaper for the student to go and rent, or excuse me, to buy that used. So value creation is this disruptive innovation plus the three circles around creative destruction. And that's what we created at Chegg. They have nonlinear growth in terms of book rentals and in revenue. Here it says the 150 going to 330. I'm going to try to hold management to those numbers, but they're doing actually very, very well. So what's the opportunities for EECS? Innovation is here and thriving in a big way. And EECS is the leader in the College of Engineering. And you should be proud of that. 40 to 50% of the patents that are being issued out of the College of Engineering come out of EECS. That's highly disproportionate given that there's 13 schools. So I think like we should get extra merit awards or extra awards, extra money from the dean. I think it should be a disproportionate amount of allocation of resources for the disproportionate amount of productivity. And then invention disclosures. Likewise, they are the leaders in disclosures at the university. So there is no shortage at all of invention. And what about what happens? I mean, with all this invention, is there anything coming out of it? Well, I would say that there's more invention, that there's actually disruptive technologies because of all the spin-outs that are coming out of EECS. And you should be pretty proud. I don't think engineers necessarily do a big job of marketing or tooting their own horn, But I think it's really important for you to collaborate with one another and learn from one another about what these kind of companies did well and why they were successful. And some of the founders of these companies are around you today. So the other thing is you say, well, some of these companies are just local, and what about the bigger companies? You guys in Silicon Valley are creating these other companies, and what about them? What about EECS's influence there? Google, Sun, and DoubleClick, huge perennial companies that not only created equity value for shareholders, but totally transformed a market, were founded by EECS students, or former students. That's amazing. I mean, amazing. You look across the country, I don't think a lot of schools can claim that kind of impact. And so you should be very proud, but you also should learn and model from their success and understand how they did it. And just a quick anecdote, because I know the professor mentor at Stanford who used to mentor a lot of the graduate PhD students, and he was a good friend of mine, who mentored the boys at Google. And actually the problem they were first trying to solve was one that was impossible, but he didn't bother to tell them that. He asked them to take, because he realized they had a lot of passion and that they were onto something. And he had a lot of understanding about where the technology could go, but it needed to be developed more. So he encouraged them. And he was a facilitator and mentor, and they developed the technology. And at one point, he started asking them different questions that led their research and work to move to a different approach and a different application for search. And I think that's what happens with a lot of great innovation, a lot of great startups with value creation, is they go through a lot of iterations. They overcome, because they don't look at it as failure, they look at experimentation. They look at it the scientific method. And they keep asking the questions and keep experimenting. And I think that is what creates a lot of value. So the question is, what's stopping you? I was surprised to see the data here. You look back at the master's and doctorates degrees, and it's pretty steady. You can see some blip, basically shortly after the dot-com bubble. But if you look at undergraduate degrees, it's waning, especially in EE, where Larry and I got our degrees. And it begged me the question. I mean, is there an issue that people think, well, all this stuff is being done in Silicon Valley? Is the question that, it's all China and India now? Help me understand, why would there be a reduction in the enthusiasm getting degrees in EE or CE? Does anyone have an idea? Think there's bigger problems to solve?
I think there's a lack of fundamentals taught in like math and science in high school, and that discourages a lot of kids when they come to college to pursue technical degrees. That's pretty fundamental. I think that, oops, there we go again. You would hope that our political leaders would be able to do something about that fundamental problem. But for me, I don't see an environment and more of need of the skill set of EECS than there is today. And I don't see the opportunity set any bigger than it's ever been than it is today. So I think you're really privileged to be in this position, and I encourage you to use the skills and the specialized knowledge you have here to develop expertise. And I think there's an opportunity for that, and I'm going to go over it right now. One thing I had heard is that some students might believe, well, there's bigger issues like energy issues to solve or healthcare issues to solve. And as I gave you that kind of example with respect to me taking fault-tolerant design techniques into a communications environment, I think some of the best opportunities is when you have specialized knowledge and expertise, applying it to an application or an environment that other people define the problem. So with your skill set, there is all these problems out there to solve. Big, big problems. And bioengineering, healthcare, security, energy, all of them requiring a lot of skill set in EECS. Because of limited time, I'm just going to focus on one. I could spend 20 minutes just on this slide.
You know, there are some scary statistics out there around our environment because of CO2 emissions, and because of fossil fuels that we use and depend upon. Not to mention the geopolitical risk that exists that affects us and will affect our children. What are we doing about it? And you say, well, that's not my problem. There's politicians there. And how can I solve that? I'm not a chemical engineer. And, you know, what about all these alternative energies, you know? You talked about algae before. Won't that solve it? What about windmills? What about solar? You know what the number one thing we can do to solve our energy problem in the short term? Use less. That's right. That deserves 2 books. I'll give them to your friends. Okay. Yeah, 57% of the energy that is consumed is wasted. Wasted. If we could provide, with technology and the answers that we have in EECS, to figure out how to first of all monitor it, and then maybe do some proper allocation of costs, incorporating costs of the environment. And maybe that's not in the real pricing, but if we make people aware of what those costs are and what the prices should be, that will influence people, influence their behaviors. And who can develop those kind of technologies and controls of the electrical grid system? You guys. That's who can do it. And this is a big problem. It's an immediate problem. And whoever solves the top 20 problems in it are all going to be billionaires. It's that, look how big the market is, 1.2 trillion. That's a big market. There is plenty of problems to solve, and that's just energy. So I would challenge you to come up with an area that you can apply this framework and do some creative destruction. And so with that, I'm going to throw down a big, big, big challenge right now. And the reward will be worth it. So I want to know who here today would like to take the challenge of using this framework to solve a very, very big problem that they're passionate about. Raise your hand. Anyone? Okay. Okay. All those people who raise their hand, who would like to have a pair of tickets to the game tomorrow on the 50-yard line? Okay. And of those people who raise their hand, I'm going to give a pair of tickets away to the 50-yard line to the first of those people who raise their hand who are willing to commit to doing it, and then come back and talk to the dean and talk to Khalil about your progress in 4 months and 8 months and report back to them. And if you're willing to do that, the tickets are yours. Okay. That's kind of deflating, you know? Okay, then you have the opportunity. You can give them away to one of the students then. Anyone want them? Okay, let's hand them back. Okay. So this always grabbed me. There's a lot of things been written and said about Thomas Jefferson, but what he said about himself on his own tombstone, you know, amazingly didn't mention anything about him being President of the United States or some of his accomplishments. Instead, what he wrote about as his epitaph are things that he did for other people. And that's kind of powerful to me because it says this man had a lot of purpose, had a sense of purpose. And so, you know, to me, if you're going to do something that's a lot of value creation, you got to be doing it for the sake of not just yourself, but for others. And that's a powerful thing. You know, I very much appreciate the confidence that I gained here at the University of Michigan. It gave me the confidence to tackle big, big problems and not be afraid to go after them. It gave me a skill set. It gave me a skill set to have this intellectual discipline to synthesize huge complex data sets, which sometimes annoys other people when I do that. Because they say, why do you have to do it all? You know, because you want to know. You want to know what the most important variables are and what aren't. And it gave me this analytical rigor to really dissect and solve problems. And I'm very grateful. You know, I grew up in an area that
You know, I have a friend who, you know, works 3 jobs just to make ends meet. So, you know, we're blessed. We're blessed with a gift. And I appreciate it. So, you know, to me the challenge isn't, you know, because each and every one of us has gotten something special in our experience set. And I think the question becomes not what it's done for me, but I think the question is, what do we do for others? And so with that, I'll say, be leaders and best, and go blue.